Naming ionic compounds with polyatomic ions. Again, we're still naming ionic compounds. In this case, though, we're going to have more than just two elements. On the last ones we did, they were binary compounds, so we only had two elements involved. Here, as you can see, we have more than two elements. We actually have 1, 2, 3, Ca, P, and O. So anytime that you see this, you're going to look for the polyatomic ion in your compound. The polyatomic ion is one that has more than one element bonded together to make an ion that will then go bond with something else. In this case, it's in parentheses, which makes it a lot easier to see. PO4 is our polyatomic ion. Now what we can do to make sure that we found it correctly is check our polyatomic ion chart. So if I look on here, I find PO4, which is right here, and it's phosphate. So the name of the polyatomic ion, PO4, is phosphate. Now make sure you're aware that it's never anything but PO4. Alright, phosphate is only the name for PO4. And the reason why you have to be real careful about this is if you look like here at nitrate versus nitrite, nitrate is NO3, nitrite is NO2. So that little bitty difference does change the name of it. It'll also completely change the chemical makeup and the chemical properties of a substance. So always make sure you keep that subscript the same. Never change it. So in this case we have PO4 phosphate. And we know that Ca is calcium. These are actually pretty easy to name. I don't have to worry about the subscripts. I just name what I have. Ca is calcium. PO4 is phosphate, so I would write calcium phosphate, and that's the name of my compound. Then if you look here, you'll see NH4 is in parentheses, so this is also a polyatomic ion. Usually the polyatomic ions are only at the end, but there are a few exceptions, not very many. NH4, which is ammonium, is one of the exceptions to that rule. Now when we get down here to the bottom, where we have transition metals, this is just like we did on the last worksheet, except now instead of looking up the charge of an element from the periodic table to determine what number we put in Roman numerals, so we're not going to look on the periodic table now to find the charge. Instead, we're going to look at our polyatomic ion chart, and it will tell us the charges of the different polyatomic ions. So let's do the first one together. AuPO4. When I look on my periodic table, I see that Au is gold, and we just looked at PO4. Remember, PO4 is phosphate, and it shows me here in my chart, I go straight up from here, and my charge is -3. So phosphate, PO4, has a -3 charge. PO4 is -3. Which means, again, remember, these two have to cancel each other out. So if this is -3, this has to be +3. I don't have any subscripts, so +3 is the charge of that element. So in this case I would write gold 3 phosphate. Okay, so again you're looking up these polyatomic ions, find their charge to find the charge of the first element. If we look down here, this is one that kind of trips people up a little bit. C2H3O2 is actually the same thing as CH3COO. See how there's two C's? Let me move this over so you can see what I'm talking about. Put them next to each other. C2, two C's, H3, O2, OO. So when you get to this one, it's actually asking you about acetate. So they're written different ways, but they are the same polyatomic ion. So don't forget to put the Roman numeral in parentheses. If you end up with any that should be 4, again, IV is the Roman numeral for 4. And if you still have any questions, please feel free to ask.